Action!
Hello, welcome. Today we're going to be doing a classic icebox problem. So, a vial of SO2 0.522 moles per liter and O2 0.633 moles per liter react and reach equilibrium. Calculate the equilibrium concentrations of the products and reactants given that Kc, the equilibrium constant, is 5.66 times 10 to the negative 10 for this reaction. 2 moles of SO2 plus 1 mole of O2 reacts to create 2 SO3 at equilibrium. So for the icebox, we're going to put in the initial molarity or concentration, which is equal to moles per liter, which is given. So for SO2, it is 0.522. And for O2, it's 0.633. And then for SO3, it is 0 as they react to create it. And then we look at it to see what's going to change in order to reach equilibrium. And we see that SO2 and O2 will decrease. O2 by a factor of 1 because the stoichiometric coefficient is 1. And then SO2 by a factor of 2 because the stoichiometric coefficient is 2. And then as these decrease, it will yield SO3 and create that, and that will add. And then we combine these to find our equilibrium concentration, which will then be equal to 0.522 minus 2x. And 0.633 minus x and 2x. And that is how you set up your icebox.
Alright, so now we're going to work on the next step of this problem, which is setting up the equilibrium concentrations compared to the equilibrium constant. And so first we can make this formula based on our reaction. So the equilibrium constant equals SO3, right here, our product, squared, because of this 2 here, over SO2 squared, because of this 2 here, times O2. And these are our reactants, and they go on the bottom. So now we're going to set this equal to our values from our equilibrium concentration and the value of Kc given to us in the problem. So it's going to be 5.66 times 10 to the negative 10, right here, equals our value for SO3, which is 2x, squared, over our value for SO2, 0.522 minus 2x squared, times our value for O2, 0.633 minus x. And that one is not squared. Okay, so now that we're here, we can use the assumption that we've learned, because this is times 10 to the negative 10, which is very small. And with the assumption, we're saying that this x is so small that when you subtract it from 0.522 or 0.633, that it really doesn't make that much of a difference at all. So what we can do is change 0.522 minus 2x to just 0.522 squared. And we can change 0.633 minus x to just 0.633. So this is a lot easier of a problem to solve. So now, we can do 5.66 times 10 to the negative 10 equals 4x squared over 0.522 squared times 0.633. And then here, when we cross multiply this and solve it out, we get 9.7625 times 10 to the negative 11 equals 4x squared. And then we divide both sides by 4, and we square root this whole thing, and we get x equals 4.94 times 10 to the negative 6 m equals x. Okay. All right, so now we're going to check to see if the assumption we made over here is valid. So what we're going to do is take this number for x we found, the new number for x, 4.94, 0.94 times 10 to the negative 6. And we're going to put that over the initial value for x, which is 0.633. And then we're going to multiply this by 100% and see what we get. And if this number is less than 5%, then we know that our assumption is valid. And when you do this math, you get 7.8 times 10 to the negative 4%. And that's a lot less than 5%. So we know that the assumption we made is valid.
So we found x, so we're done with the problem, right? Well, no, it actually asks for the equilibrium concentrations of the products and reactants. So let's find those now. Here's the concentration of SO2, O2, and the product SO3. And the concentration of SO2 at equilibrium is going to be 0.522 minus 2 times x, which is 4.94 times 10 to the negative 6 molar. And since that value is so small, just like we said before, 0.522 is going to be your final value with the right number of sig figs. So that's the final concentration is 0.522 molar. The concentration of O2 is going to be 0.633 minus 4.94 times 10 to the negative 6th. Again, that value is so small that it doesn't affect the concentration, so the final concentration is going to be 0.633 molar. And for the concentration of SO3, the final, it's going to be 2x, so 2 times 4.94 times 10 to the negative 6th, and that equals 9.88 times 10 to the negative 6th molar. So here are your final concentrations. And now you're done with the problem.
Thank you, Eric.